Hello, I am Devshika Patnaik, registration number 19BC1292 of G2 slot. So this is my digital assignment 2 for the subject of machine learning. So I am doing a priori algorithm. So a priori algorithm is given by R. Agarwal and R. Shrikant in 1994 for finding frequent item sets in a dataset for Boolean association rule. The name of the algorithm is a priori because it uses prior knowledge of frequent item set properties. We apply an iterative approach or level-wise search where k frequent item sets are used to find k plus 1 item sets. Uh, and in this, we improve the efficiency of level-wise generation of frequent item set. And an important property called the a priori property is used. This a priori property helps in reducing the search space. So let's see what is a priori property. So a priori property. All non-empty subsets of a frequent item sets must be frequent. The key concept of a priori algorithm is its anti-monotonicity of support measure. A priori assumes that all subset of a frequent item set must be frequent. And if an item set is infrequent, all its supersets will be infrequent. So let's see the working of a priori algorithm with an example. So this is a transaction data set, and item one, item two. The first transaction is item one, item two, item five, and like this. The transaction data set, and the minimum support is 2, and the minimum confidence is 60%. Okay, let's start with step one. This is the iteration one. Where k is equals to 1. First, we'll create a table containing support counts of each items present in the dataset called C1. So in this, the item 1 appears in the dataset 1, 2, 3, 4, 5, 6 times, and the item 2 appears 2, 3, 4, 5, 6, 7 times, and similarly, all the appearance of each items are written here. Then we'll check whether all these number of counts are less than or greater than minimum support. If it is less than, we'll remove that item. If it is greater than, we'll keep that. Since all the items I1, I2, I3, I4, and I5, all of their count is greater than support, minimum support. So we'll keep this table as it is, and this will be our L1 list one. Okay, then we'll go to the second step. Generate candidate set C2 using L1. The condition of joining is that it should have a k minus 2 elements in common. Here k is 2, so k minus 2 is 0 elements in common. So we can generate permutation, different permutations. For example, I1 with I2, then I1 with I3, I1 with I4, I1 with I5, then I2 with I3, I2 with I4, I2 with I5, I3 with I4, I3 with I5, and I4 with 5. Then we'll check all these occurrences in the transaction table. So all these occurrences are mentioned here, as you can see. Then remove item set with support less than equals to minimum support. Here this I4 and I5, I3 and I4, I3 and I5, I3 and I4, and here I1 and I4. These are support is less than 2. So we'll remove all this, and this is our new list, and this is L2. Okay. Then we'll proceed to the step 3. Here k, the value of k is 3 here. So generate candidate set C3 using L2. Condition of joining is that it should have k minus 2, that is 3 minus 2, 1 elements in common. So here for L2, first element should match. So item sets joining by generated by joining L2 is I1, I2, I3, then I1, I2, I5, I1, I3, I5, I2, I3, I4, I2, I4, I5, I2, I3, I5. Let's say in this. Here, these two are first elements are common, so we can join these two. I2, I2, I1, I2, I3. Similarly, I1 here, these two I1, I2, I5. Then I1, I3, I5. Similarly, you can perform and check if all the subsets of these item sets are frequent or not frequent. Then if not frequent, then remove that item set. Here for subset of I1, I3, I1, I2, I3, we can derive it as subsets. I1 and I2 is one subset, I2 and I3 is another subset, and I1 and I3 is another subset, which here all the threes are frequent. All the three of them are frequent. So this total set is frequent for I2, I3, I4. The subset I3 and I4 are not frequent. So we'll remove it. Similarly, check for every item set, find support of these remaining item set by searching in the data set. Here, we'll search here. So this, then I1, I2, I3 support is 2. I1, I2, I5 support is 2. Here all the support count is greater than 2. So the list will be remain as it is. And then let's go to step 4. Generate candidate set C4 using L3. Condition of joining is that they should have k minus 2 elements in common. Here k value is 4, k minus 2 means first two elements must be common. So here L3 first two elements should match. So check all the subsets of this item set frequent or not. So first two elements are common, so we can take I1, I2, I3 and I5. So its subsets are I1, I3, I5, which is not frequent. I1, I3, I5 is not frequent, so no item set in C4. So since there is no item set, so we'll stop the process here. So let's see the working of Apriori algorithm using RapidMiner. So I have already designed a process. So first I have retrieved let me go to the data set. So here it is a transaction data set. The first transaction, there are 20 transactions in total. The first transaction has biscuit, bread, and milk. So these are yes means these three items are present. Similarly, 20 items are here. So in this first I have imported the data set. So as you can see here, there are some missing values and the values which are the items which are present in the transaction are marked with yes. So first I have retrieved it and then I have replaced the missing values here. As you can see, replace the missing values with 0. And then in the next step, I have replaced all the entries with yes, with replaced by value 1. And then this guess step, this part I have used it to convert, since all the entries are in polynomial form, so I have used it to convert polynomial to numerical, or that is integer. Then I have converted numerical to binomial. In this step, since FP growth will only use binomial inputs, will only take binomial input, so I have used it to convert numericals to binomial. Then I have this output of this numerical to binomial goes to FP growth, and here its output goes to create association rules. So here the minimum confidence which I'm taking is 80%, and here the minimum support is which I'm taking is 95%. So when we'll run this, we will get a result, as you can see. Okay, let me run it. Here is the data. Premise is milk and conclusion is bread. That is when one will description. Let's go to when one will buy milk. then there is a 80% chance that he will buy bread, and when he will buy Maggie, there is a 80% chance that he will buy tea. So as you can see, here is the graph. This is the rule 1 and this is rule 2, and here in the data you can see the support is 0.2, 0.2, confidence is 0.8, Laplace is 0.96, gain and different attributes are written here. The graph is also here. Okay. So with this, I will conclude. Thank you.